Hi class, in this video we're going to talk about Laplace transforms. And we're just going to start off with some examples which go from the regular or time domain into the transform domain. So I'm going to start with number 2. We have y of t is e to the 3t minus 2 to the t. And the thing to notice is while e to the alpha t is on our chart, 2 to the t is not. So before we get started, we're going to have to use our exponential rules to transform 2 to the t into a base e exponential. So 2 is e to the log of 2. So we first write it as e to the log of 2 all to the t, and then we use our exponent rules to get e to the 3t. Nothing's happening there. Power to a power we multiply, so this should be log of 2 t. Okay, once we've written it like this, now it's not too hard to figure out the Laplace transform. In fact, both of these use the same rule. The first one is 1 over s minus 3, and we'll have a minus sign from this minus. And the second one is 1 over s minus log of 2. So that's it for number 2. We first have to get our exponential function base e, and then once we do, we can use our chart just to transform. And that's all there is to it. The next example that I'd like to show you is number 4. In this case, we have y of t is e to the negative 4t times cosine of 3t. And while it's tempting to just take the Laplace transform of the exponential here and the Laplace transform of the cosine term, this is not going to work. If we peruse our chart, we find some rule which looks something like this. If we have e to the omega t f of t, this is the Laplace transform of f evaluated at s minus omega. So we're going to use this rule, and what happens here this is the Laplace transform of cosine of 3t evaluated at s plus 4. Notice I keep saying evaluated instead of times. This does not represent multiplication. It's evaluation at the quantity s plus 4. So as we go through, the Laplace transform of the cosine of 3t, I'm going to write this using u's. It's u over u squared plus 9, and I'm going to evaluate at u equals s plus 4. Okay, so now all I have to do is plug in u equals s plus 4 and I'll be done. And there we have it. The Laplace transform of e to the negative 4t cosine 3t is given by s plus 4 divided by s plus 4 quantity squared plus 9. And you could multiply this out on the bottom, or you could leave it like this. It doesn't really make any difference. Okay, the final example that I'd like to show you is number 9. I'm sorry, number 7. Ooh. This one's going to be a little bit longer. We have y of t is sine of 2t plus cosine 3t, all times the Heaviside function evaluated at t minus pi. Okay, for this one we need the rule that says something about the Heaviside function, and in particular we need the rule that has the forward arrow, or the arrow that moves from left to right on your table. So that looks thusly. If we have g of t, Heaviside function of t minus a, evaluated s, if that's what we want to calculate, well, what we end up doing is getting an exponential, and then we take the Laplace transform of g evaluated at t plus a. Okay, so using this rule, we're going to have to figure out what g of t plus a is. So in our case, what we get is the Laplace transform of sine of 2t plus cosine 3t all times the Heaviside function of t minus pi is e to the negative pi s, that part's not too big of a deal, times the Laplace transform of, I'll have a chair in the way. Sine of 2t plus pi plus cosine of 3t plus pi, evaluated at s. And the rest of this problem is going to actually be figuring out the sine and cosine addition rules. So continuing to simplify here, distributing the 2 through, we get sine of 2t plus 2 pi plus cosine 3t plus 3 pi, evaluated at s. And now we need those rules. The sine, I'm going to write these in red above, if you can read that. The sine of alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. And the cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So I'm going to use these two addition formulas to simplify the inside of this. This is sine of 2t cosine 2 pi plus sine of 2 pi cosine 2t plus, and now so that's the term for sine. The term for cosine is cosine 3t cosine 3 pi minus sine 3t sine 3 pi. And before I try to take any Laplace transforms, we can simplify the inside of this because we know what the sine and cosine of 2 pi, we know what those values are, and we know what the cosine of 3 pi and the sine of 3 pi are. In particular, we're just left with the cosine of 2 pi is 1, so this is sine of 2t. The sine of 2 pi is 0, so that term just goes away. So I'll make that go away in orange. The cosine of 3 pi is negative 1, so we'll get minus cosine of 3t. And the sine of 3 pi is 0. So ultimately all we have to do is to find the Laplace transform of the sine of 2t and the cosine of 3t. So both of these are easy to find on our chart. What we get is 2 over s squared plus 4 minus s over s squared plus 9. And that's it. So when we have the Heaviside function, we have to remember that there's a shift on the inside which we have to account for first. Now, oftentimes this comes down to remembering some rule from a previous course, like in this case, trigonometry, where we need to know the sine and cosine addition formulas. If we don't know these rules, we really can't continue, or at least easily with the chart we have, because we just don't have the tools to do it. So we simplify on the inside first. That was all of this business. and then we transform.